Hello, I am Seema and welcome to part 7 of the chapter Redox Reactions. I was telling you about the different categories or the different kinds of redox reactions. And I told you that there are 4 kinds of redox reactions. The first 2 categories we did in part 5, where I told you about combination reactions and decomposition reactions. In part 6, I told you the third category of redox reactions, which were displacement reactions. And now in this video, I'm going to tell you about the fourth category of redox reactions, and which are known as disproportionation reactions. When we talk of something that is not proportionate, disproportionate, something that is not proportionate. Let us say that we have this pen here. If I hold it in the center and at exactly the center, the mass on this side would be equal to the mass on the other side, and therefore it is a proportionate division. But if I divide it or try to hold it from one side, the mass on this side is lighter and the mass on this side is more, because there is more of a limb to this side. So now this division is kind of disproportionate. So when we say what is disproportionation, you can guess from the term that something is happening which is related to redox reaction and which is not keeping the substance proportionate. Basically, whenever disproportionation reactions only take place for those elements or atoms of those elements which show at least 3 different oxidation states, right? If they show 3 different oxidation, 3 or more, so if they show 3 different oxidation states, in the reactant side, you must have that oxidation state which is in the middle. So you would say it is kind of proportionate. It is in the middle. But when the reaction takes place, this element undergoes both oxidation and reduction. So if its oxidation number increases, then it is oxidation. And if its oxidation number decreases, then it is reduction. And in the middle, it was an average, you could say. So what has happened in the reaction? It was as if you were holding it in the center, the central oxidation number, but when the reaction took place, one of the oxidation numbers became greater than this, so it got oxidized, and one of the oxidation numbers got lesser than this, which means it got reduced. When the same element, atoms of the same element on the reactant side undergo reduction and oxidation, such a reaction or such a redox reaction would be known as a disproportionation redox reaction, right? So let me just read the definition here. In these, an element, or in these means in disproportionation reactions, an element in one oxidation state is simultaneously oxidized and reduced. In one oxidation state means it has got a certain oxidation state, and it's simultaneously, that means some atoms are getting oxidized of that element and some atoms are getting reduced. So they get simultaneously oxidized and reduced. One of the reacting substances, one of the reactants, it must contain an element that exists in at least 3 oxidation states. This becomes clear to you why there should be 3. Disproportionation is only possible if it has at least 3 oxidation states, one condition. Second, that in the reactant side, the oxidation state should be the middle one. If it is, let us say, the lowest one, then it can only undergo oxidation, and oxidation, maybe it may show 2 different oxidation states, but it is only undergoing oxidation. But if it is the middle one, middle oxidation state, then if it decreases, it is undergoing reduction, and if it is increasing, it is undergoing oxidation. Therefore, it is necessary that this atom should be, the oxidation state in the reactant side should be the middle one if they are 3. So we say it should exist in at least 3 oxidation states, and this oxidation state on the reactant side is the middle one. An example here is the decomposition of hydrogen peroxide. It is a decomposition reaction plus it is a disproportionation reaction. In class 9 or 10, when you did the different categories of chemical reactions, you have studied that reactions may not fit into just one category. The same reaction could be a redox reaction, the same reaction could be a decomposition reaction. So there are different classes to which a reaction could belong. So this is the decomposition of hydrogen peroxide. Here you have H2O2, and what are the oxidation numbers of? In H2O2, oxygen has a charge of -1 and hydrogen has a charge of +1. In the products you get water and you get oxygen. Now oxygen here will be, since it is in the elemental form, its oxidation state is 0, and in water we know that the oxidation state of oxygen is -2. In other words, this was -1. From -1 to -2, it means the oxidation number has decreased. So the oxygen has undergone reduction. And from -1, it has increased to 0 when it formed oxygen. So oxygen gets oxidized to form O2 and it gets reduced to give you H2O. So oxygen here is undergoing disproportionation, and therefore the decomposition of hydrogen peroxide on the whole, the reaction is known as a disproportionation reaction. If we take a few more examples, phosphorus, sulfur and chlorine undergo disproportionation in alkaline medium, and these examples have been given. In alkaline medium means that what is an alkali? As a base which has OH negative in it. So in alkaline medium, when we say you have phosphorus, it reacts with 3 OH negative with 3 H2O. So we are going to, the element which is going to undergo disproportionation are phosphorus, sulfur and chlorine in these 3 reactions. Therefore we'll focus on the oxidation states of these 3. The rest, of course, we know are going to remain the same. Phosphorus here is 0, and in pH, it results in the formation of pH3. In phosphorus trihydride, pH3, the charge on phosphorus is -3, while hydrogen has a charge of +1. Hydrogen being more electropositive than phosphorus. Therefore, it has a charge of +1, but phosphorus has a charge of -3. And it also forms H2PO2 negative, where in H2PO2 negative, the charge on phosphorus is +1. So phosphorus from 0 went up to +1, which means it got oxidized, and from 0 it went down to -3, it got reduced. Therefore phosphorus here is showing disproportionation, and the reaction is a disproportionation reaction. S8 has a charge of sulfur in S8 has a charge of 0 because it's in the elemental state. It again reacts with OH negative, results in the formation of S2 negative, the sulfide ion, and S2O3 2 negative. Now in S2 negative, you know 2 negative, the charge is 2 negative, and in S2O3, oxygen is more electronegative than sulfur. Therefore, in comparison to oxygen, sulfur is positively charged. So you have 3 oxygens, so oxygen has a charge of 2 negative normally, unless it's a peroxide. So if it has a charge of 2 negative and the entire species has a charge of 2 negative, right? So which means that there should be 4 positive charges. So there are 2 sulfurs, each sulfur will have 2 positive charges. So 4 positive charges, 6 negative charges will make the entire species 2 negative. I hope I'm clear what I'm telling you here, because I'm not going to go into details of this. How do we find out the charges? Maybe I'll do a video in which we will do this, that how do we estimate or how do we find out what are the charges on each atom. But anyway, I've already told you how to calculate the oxidation number or the oxidation state. So refer to that video, see it, and I would encourage you to do that so that it becomes very easy for you to know the oxidation states of each atom in a compound or in an ion. So here sulfur has a charge of +2, and here it has a charge of -2, and in S8 it had a charge of 0. So from 0 to -2 it got reduced. From 0 to +2 it got oxidized. The next example is chlorine. Chlorine is 0 again, and it reacts, it should be Cl2 here. It reacts with OH negative, and it results in the formation of ClO negative and Cl negative. In ClO negative, again, oxygen is more electronegative than chlorine. Therefore, chlorine becomes positively charged, and oxygen has, unless it is a peroxide, it has a charge of -2. And chlorine has a charge of either -1, but here, since it is combined with oxygen, it is more electropositive. It shows a charge of +1. Because if it had a charge of +2, then this would have been a neutral species. But since it has a negative charge, it means oxygen has two negative charges. One of the negative charges is being neutralized by chlorine. So therefore, the charge on chlorine should be +1. And in this, in Cl negative, of course, it has a charge of -1. It is pretty evident from the species. So chlorine undergoes from 0, it goes to +1, it means it gets oxidized, and from 0, it goes to -1, which means it gets reduced. So this is a disproportionation reaction. Now, having understood this, let us take the example of fluorine. Fluorine also undergoes reaction in alkaline medium, but that reaction is not a disproportionation reaction. The reaction that takes place, let us first see what it is. When fluorine reacts with 2 OH negative, it results in the formation of 2 F negative. Now, in F2, the charge on fluorine was 0. In F negative, it is negative, 1 negative. And it forms OF2 compound plus H2O. Here in OF2, fluorine is more electronegative than oxygen. Therefore, oxygen shows a positive charge and fluorine again shows a negative charge. Oxygen has a +2, therefore there are 2 fluorines, each one would have a -1, therefore it results in the formation of the compound OF2. So what happened? In OF2 and in F negative, in both of these, fluorine has a charge of -1. So what happened? Fluorine here had a charge of 0 in the elemental state. It only reduced to -1 in both the compounds that it formed. It carried out the reaction only, it was not a disproportionation reaction. Fluorine only went from 0 to -1, it did not go to a positive value, and there is a reason for it. That fluorine is the most electronegative element in the entire periodic table. And therefore, in comparison to fluorine, all other elements would be positive. So fluorine can never show a would never show a positive charge. It would always show a charge of -1. When we studied the how to assign oxidation numbers, this is also something that I explained to you. So fluorine would only have the charge -1. It would never be positive in comparison to any other atom. And therefore, it does not show disproportionation reaction. Now, there are 2 solved examples given in your textbook, and I would like to explain these 2 solved examples also, because that will make this very clear to you, the different kinds of the different categories of. The first question deals with disproportionation reaction, but the second question deals with all categories. So let us do these 2 questions in this video. The first question is question 8.5. It is the example 8.5. Which of the following species do not show disproportionation reaction and why? 4 species are given to you. The oxides of chlorine, the ions ClO negative, ClO2 negative, ClO3 negative, and ClO4 negative. Let me just assign the charge on chlorine in each case. Oxygen is more electronegative in comparison to chlorine. And none of these is a peroxide. So in all of these, oxygen has a charge of -2. There is one oxygen, it has a charge of -2, and the entire species has a negative charge, which means one of the negative charges has been neutralized by positive charge given by chlorine, and the other negative charge remains. So in this ClO negative, the charge on chlorine will be +1, right? In ClO2 negative, now there are 2 oxygens, therefore there are 4 negative charges. Each oxygen has a charge of -2. But the entire species has a charge of -1, which means that 3 of the negative charges have been neutralized by chlorine. So what is the charge on chlorine here? What would be the oxidation number of chlorine? It would be +3. In ClO3 negative, what would be the charge on chlorine here? 3 oxygens makes it 6 negative charges. Since the entire species is negatively charged, one of the negative charges is not neutralized. So you're left with 5 negative charges. Therefore, chlorine should have provided 5 positive charges in order to neutralize the 5 negative charges. Therefore, the oxidation number of chlorine here would be 5 plus 5. In ClO4 negative, now you have 8 negative charges, out of which 1 has not been neutralized. So you have 7 negative charges which are neutralized by chlorine. Therefore, in this ion, chlorine is showing an oxidation state of +7. Now, I had explained to you that if you had to calculate the maximum oxidation state of any substance, of any element in any group, you have this table. These are the different groups. For the first and the second group, the highest oxidation state is the number of the group. But from group 13 onwards, it is 10 plus that number, right? Plus 10 plus the number of electrons in the outermost shell. So, therefore, for group 1, group 2, group 13, group 14, 15, 16, 17 elements, the highest oxidation states are plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7. And chlorine belongs to the halogens, that is the 17th group. Therefore, the plus 7 oxidation state is the highest oxidation state. Being the highest oxidation state, what was our condition when we carried out the disproportionation reaction? We said that if it is the reactant, then this substance should have at least 3 oxidation states. 1. Yes, we noticed that chlorine does have 3 and more oxidation states. But if it is the highest oxidation state or the lowest, it will not disproportionate. It can only disproportionate if the oxidation state on the reactant side is somewhere in between. So here we find that out of all of these species, it is this one, that is ClO4 negative, which has an oxidation state of plus 7, and this would not disproportionate. So let us see what our 3 reactions have been given to you in the textbook explaining the disproportionation reaction in these 3 which do undergo. I don't think you were expected to know these reactions on your own. These have been put there in the example on purpose for you to understand the topic better. And as far as I think, you're not expected to memorize them also. All you have to do is to understand how the disproportionation is taking place. In a question during the exam, you might be given an example of this kind where you would be asked to identify the kind of reaction. And there you must remember that you've done this example in disproportionation reaction. So let us see what happens. How are the disproportionation reactions? In ClO negative, there are 3 ClO negatives give you 2 Cl negative and ClO3 negative. Here the charge on chlorine is plus 1, in Cl negative it is minus 1, and in ClO3 negative it is plus 5. We've already calculated. So the chlorine here is getting disproportionated. It is getting reduced from plus 1, it is going to minus 1, and from plus 1 it is going to plus 5. Therefore it is getting oxidized. Second example, you have ClO2 negative. Here the charge on chlorine is plus 3, and it results in the formation of ClO3 negative, which is plus 5, and Cl negative, which is negative 1. So from plus 3 state, it is going to minus 1, it is getting reduced. From plus 3, it is going to plus 5, it is going up to plus 5, therefore it is getting oxidized in this case. Then in the next reaction, you take this, that is ClO3 negative, the charge on chlorine is plus 5, and it goes to minus 1 in Cl negative, and for ClO4, it goes to plus 7. And since it goes from plus 5 to minus 1 is reduction, and plus 5 to plus 7 is increase in oxidation state, therefore that is oxidation. So these are the different disproportionation reactions that would take place. And in the case of ClO4 negative, since the charge on chlorine in this ion is plus 7, therefore this cannot disproportionate since it already has chlorine in its highest oxidation state. Therefore it can only reduce in oxidation state. That is, in this chlorine can only reduce, it cannot get oxidized further. Therefore this would not show disproportionation reaction. Now give me a moment to write down one more question before I wind up this video. Now this is the question 8.6. It is the solved example of your textbook, and let me read the question. You have to suggest a scheme of classification of the following redox reactions. You've been given 4 different redox reactions. You have to identify them, whether they are, which category do they belong to. And we know there are 4 categories: combination reactions, decomposition reactions, the displacement reactions, and disproportionation reaction. And on purpose, this question has been given to you where one example of each kind has been given just as a revision, for you now to just build up that foundation and make it seal the fact that you understand all 4 categories of the redox reactions. So let us do the first one. N2 combines with oxygen to give you NO. Whenever you have one product and more than one reactant, it means all those reactants are joining to give you one large molecule. Such a reaction is known as a combination reaction. And since all 4 are redox reactions, we already know, we don't really need to go searching where the redox is occurring here, because this is a clear-cut case that it is, there are different reactants are combining to give you one large molecule. So this is a combination reaction. Combination. Then in the second question you have lead nitrate. It gives you lead oxide and nitrogen dioxide, NO2, and half O2. Now you have one large molecule which is breaking down to give you smaller molecules. So on the reactant side you have only one reactant and the products are more than one. Whenever this happens, it is the opposite of combination, which is known as decomposition. So we say that this reaction is an example of a decomposition reaction. Right? Very easy. Whenever you have small molecules building one large molecule in the product, it's combination. Whenever you have one large molecule making smaller molecules in the products, it is the opposite of combination, that is decomposition reaction. Both of them are redox reactions. Then the third category, you have sodium hydride, NaH, combining with water to give you NaOH and H2. Now look at this. Water molecule is made up of H positive and OH negative, you could say, right? Now, or H and OH, right? Whether you call it positive or negative, that you could even ignore that here. Water is made up of H and OH. Now, this hydrogen in sodium hydride gets replaced by OH negative to give you NaOH. And the hydrogen here and the hydrogen here combine to give you H2. So what has happened here? OH negative or OH from the water molecule has combined with, has replaced H positive here or the hydrogen here, and therefore the the H negative here, sorry, because the H negative and H positive of water together would result in the formation of H2, which would be neutral. Anyway, not going into the charges, OH from here replaces the hydrogen from sodium hydride. In sodium hydride, sodium being an alkali metal has positive charge and hydrogen has a negative charge. So sodium hydride would have negative, the charge on hydrogen is -1 here, and when it moves and combines with H positive here, the OH negative replaces the H negative. Therefore, this category, what category of reaction would this be? This would be a displacement reaction. This is a displacement. And of course, the fourth category is a disproportionation reaction. We already know what it's going to be like, but let us just see the evidence here. You have NO2 combining with OH negative in basic medium. It gives you NO2 negative and NO3 negative and water. So it is nitrogen which is forming more than one product. So therefore we would like to focus on nitrogen. And oxygen, unless it is a peroxide, would always have a charge of -2. Therefore, we do not see oxygen here, would usually have a charge of -2. So it is nitrogen that we are going to put our focus on. In NO2, oxygen has a charge of 2 negative. Therefore, there are 4 negative charges and nitrogen has a charge of +4 here. In NO2 negative now, there are 4 negative charges and the nitrogen is fulfilling only 3 of those charges because it has a negative charge. So this has, nitrogen has +3, charge +3 here. And in NO3 negative, there are 6 negative charges, out of which 1 has not been neutralized. So there are 5 negative charges being neutralized by nitrogen. Therefore, the charge on nitrogen is +5. So what were the 3 oxidation states of nitrogen? From +4 it goes to +3, that is, it is reducing, so here it is undergoing reduction. From +4 it is going up to +5, so it is getting oxidized since the oxidation number is increasing. Therefore, this fourth reaction is an example of a disproportionation reaction. So that was disproportionation reactions and the different categories of reactions. With this, I'll wind up this video. If you found it helpful, give it a thumbs up, subscribe to my channel, recommend it to your friends, and please keep returning for more videos in chemistry. Thank you for watching, and bye-bye for now.